Hello, I'm back in the part 2 in the series, and let's start with UML class diagrams. Okay, so what is a class diagram? It's like a data diagram with the methods inside. We have classes, their relationships between the classes. Um, Now, class diagram is level above the data diagram, so we know some of the functionality that's in there, but it's still not a complete representation of the system. So what is missing is the part that's missing is the interaction between classes. You know that there are some multiplicity relationships, maybe there are some static information, but not about the interaction, like which one goes where. The other thing that's missing is the algorithms. You don't know how those functions are implemented. You have the names of the functions and some description, but you don't know how they're done. Also, the trivial methods, you're not supposed to show those trivial methods like get and set methods in class diagrams. The classes that we know that they exist, like standard Java libraries, we don't want to put them in these diagrams to make the diagram simpler. Next slide. I'm going to show some examples of these class diagrams and show some details of these the syntax in there. So first of all, the name can take a few forms. So it's like in the data model, it's the name of the class. Now if you put these angular brackets and you say interface, then it becomes then you're representing an interface class. An interface class is basically a definition of a class that's only the names of the functions. There's no implementation. It just tells you that this class must have these functions. Another different type of class is the abstract class, and if you write to represent an abstract class in UML, you have to write it in italics. The title must be in italics. For the attributes, we should list all the attributes in here, and you can see we have for this rectangle we have the width and height, and we also have the area. However, actually the area is very can be easily calculated by multiplying the width and height, right? So it's kind of redundant here, but even though it's redundant, it is needed by these functions, the methods, so we should still include it in here. Now these redundant the redundant attributes that are dependent on the other attributes, they're called derived properties or derived attributes, and they are represented by the slash, and we'll talk about these signs at the beginning. The methods, you can see this is the constructor, which has the same name as the class name. It takes these two inputs, the name of the input column and then the type of the input. This is how you write it, the same way in here. And here's a method, a distance method, that takes a single argument r, which is a type rectangle. So basically this rectangle's distance to the actual rectangle will be returned as a double. So this is the return type at the end. As you can see, we don't have the get and set methods in here, but here in this example we do have get and set methods, so it's dependent on the application. But we don't show the inherited methods. If this is a subclass, we're not going to show the inherited methods from the superclass. Next slide. Let's focus on the attributes and talk about the signs that precede the attributes. You saw that these are minus signs or dashes. That means it's a private attribute. What is a private attribute? It can only be accessed within this class, as opposed to, for example, a protected attribute, which is shown with the hash sign. It can be accessed from this class and any subclasses within this class hierarchy. So it's less private than private. And the the easiest access is provided by plus, which is public, meaning it can be accessed from outside, from any class. Now more restrictive is package. This is the default apparently. Package meaning several classes may be within one package, so all those classes and their subclasses will be able to access this. And the slash, as we said before, is a derived attribute. Yeah. Now the underline, which you see in the student class, also has a meaning. It means it's a static attribute. Now what is a static attribute? Here let's look at this example. So it's a student class that has the name of the student and an ID of the student, and there are some methods. Now there's also total students. It's a number, it's an integer. So why would so each student has a name and ID, but how come each student can have a total students? It kind of doesn't make sense, right? Like total students should be like outside, maybe here, for all of these instances of this class. Then you can have a total students number. But then if you put it outside of the class, then you have to put it in another class, right? Kind of you need to create another class just to put this value inside. So this kind of doesn't make any sense either. That's where we have these static attributes. Static attribute is actually associated with this class and not the instances. So when you have a student, when you have an instance of this class, student name Mike, ID number 21, that student will not have a different total students, but when you access the number, it's going to be the class's number. And every time you add a new student, if you increment that number, it's going to be like a global variable within this class, basically. So this value will be for all the students in that class. Anyway, we can talk more about it. If you have questions, you can ask me later. Here you can see some examples of different access visibilities. So the hash is a protected method. Plus is public, so everybody can access the name, but the ID cannot be accessed by all classes, only subclasses of this. Email is accessed only through the package, so maybe a few classes can access it. And also get total students, a static method is underlined, a static. So what does that mean? It means you don't need an instance of this class to access it. So you can just say capital student dot get total students and you can access it. Next slide. Let's look at a little bit more to those methods again. As we already learned, you have the visibility, sign, whatever these things, the name and the parameters, and then return type. We already talked about it. Static methods are underlined, and the only one is in here, get total students, because it's accessing a static variable or attribute. These how parameters are listed. Now return type does not exist for constructors yet, right? So rectangle returns the type rectangle object. So we know that, and we don't have to write it again in here. And also if some method returns void, then you don't have to write it, so that you don't write anything in there. Next slide. Comments can be put in these class diagrams. So we're talking about class diagrams, right? So far we just talked about the classes, and here's an example of a class without any attributes or methods. So this is a relationship between the ArrayList class in Java and the clonable interface. That this arrow means is implements this interface. Now, but there's some peculiarity in here. It's saying that the clonable is an interface, but actually it doesn't have any methods. The clone method that is supposed to define is already defined in the object class. So there is a relationship, but there's actually some caveat about the relationship. So that's why they put a note in here. So the idea is that when you're making these class diagrams, when there are some complex relationships, you can always put these notes. And the way you do it, you put a dash line and you attach it to one of these items. So we talked about the classes themselves, the boxes for the classes. Now, what can you do with those classes? How can you associate them? There are two main types of relationships that you can depict in UML diagrams. One of them is a generalization type of relationship, which means you're either inheriting, like there's a subclass and superclass, or it can be an interface, like the one we just saw, the clonable interface. The second type is association, meaning like aggregation, for example, or dependency, like something includes something else, something is part of something else, and something is made of something else. Okay, these three types are associative properties relationships. Next slide. Let's start with the generalization, like inheritance. So here you see an interface that defines no attributes, because interfaces only define methods. Now this rectangular shape implements this interface, so it is like inheriting it from it. Because it's implementing the interface, you show it with a dashed line. So let's see, interface dash line and white arrow. Okay. Now, why is this rectangular shape written in italics? Do you remember? I just told you in a few slides ago. Let's look at it. Let's look at what's happening. So it has some attributes. Now it's like the rectangle before. It's a rectangular shape. It has width and height and area. It has the constructor, and it has get area like we saw before, and then it has this method contains, which is also in italics. Now I'll tell you, so in italics, something written in italics, this means it doesn't exist. It's actually abstract. So this method, it doesn't exist yet. It just tells you that there should be a method like this in this class. But since we are talking about the general shape, we don't want to specify it. Since this method doesn't exist, it's just a definition, then this class becomes an abstract class. And only in this place, when you see an upright name and a solid line and white arrow, so from abstract class you implement it, only then when you implement that method, then you have a regular class. Okay. So, and then if you were extending this class or subclassing this class to, for example, I don't know, maybe diamond or something, or something rectangle, then you would have used this, the class inheritance line, which is a solid line with a black arrow. So this was a white arrow because it's an abstract class. And most of the time we want to depict it like this from top to bottom. So more general is on the top and more specific is at the bottom. And you want to point upright to the parents. So what's missing in here? We don't want to clutter the diagrams. We want to make things very simple, and we don't want to draw too much. So you don't want to include something trivial like putting the object class in Java, because we know that every object has the object as parent, but there is no point putting it in the diagram. We try to save some time. We try to be lazy a bit. Next slide. So that was generalization and inheritance basically, and the second type of relationship was associational. And you already know about multiplicity, right? So you draw a line and put the multiplicity like in the data model. Now the star you can use a star as a wildcard in there. Just means 0 or more. If you put a number, it means the exact number. You can put a range, so it's like 1 to many, meaning that if you put just a star, it means from 0 to many. If you say 1 to many, then it's, you know, that's starting from 1. It's not 0. It's definitely there's at least 1. The second thing, you can put a name in between these relationships. So there's a line, and you know that these classes somehow aggregate. There's some aggregation relationship in here. You can say what it is. So you can say that means class A contains class B, which means so there's a class B in here somewhere. And finally, the direction, the navigability, is represented by this diamond. I just told you that this class A includes class B. I can say that because the diamond's on towards the class B, so it's like an arrow pointing to class B. If the diamond was on this side, then I should have said class B contains class A. Okay. Next slide is multiplicity. We already know about this. One-to-one multiplicity, you can see the one numbers. And here is an example of like student carries ID card. Okay, so, and we say it like that because the direction is from student to the ID card, because the arrow is on that side. One-to-many is shown by actually this the color means something else, but here's just a one-to-many relationship from the rectangle list contains many rectangles, right? I read it like that because the arrow is on the side, and the rectangle is always in a rectangle list because there's at least one here. Other association types are aggregation, composition, and dependency. So here's the thing. Aggregation and composition are very similar concepts. Both of them is meaning is like something is made of something else. However, with aggregation, it's only like a part of kind of relationship. So like the car has an engine, like, but the car has also other stuff, right? It has doors and wheels and other things. Car is not just made up of an engine. But in composition, you're saying that something is completely made up of something else. And a good example of that is that like a book is made of pages. So if you don't have at least one page, then you don't have a book. It doesn't exist, right? So it's a stronger version of aggregation, and the parts live and die with the whole, and it's represented by a black diamond as opposed to this empty diamond, clear diamond. So these are actually a single this is one concept, and dependency is a little bit different. It just says there's a temporary relationship between the two classes, so it's like a temporary use. It's shown by a dotted line and an arrow. For example, lottery ticket has some relationship to random, like there's some random number generated at some point, but once you have the ticket, then it's not there anymore, right? You already have the ticket, and now you can get the reward if you're selected. Here are some examples. I'm in the next slide. These examples shows a few classes in here. It's a voting system. It's called the voting program. So this outside line with the tab in here, this tells us that this is a package, and this package includes 4 classes, and there's a little note. It's saying that this is a subset of the actual package. These classes don't have direct relationships, only these dotted lines that there's some temporary relationships. There's voter authentication that does some authentication through the identification of the voter, which has the names and addresses and stuff. There's a password that authentication is, at some point the password is used so that to identify the voter. There's a ballot. There are not too many relationships between these two, but they're all in the package. So this is a good diagram because it shows you the attributes, the methods, and there's some relationships. It's sufficient information for a class diagram. And also, like it helps you understand what's happening. It's good for communication among team members. Here is a little bit big diagram with more relationships. This is about a rental system, like Blockbuster. I don't know if you guys Blockbuster in the past people used to rent DVDs to watch movies before Netflix. The rental item here can be some movies like DVD movie or VHS tape movie, or a video game, and the customer can rent some of these, um, for and a rental invoice is going to be created, and at the checkout screen is going to be assigned to the customer. So here the customer will have a rental invoice. So each rental invoice will be assigned to one customer. Okay. So the rental invoice, no, the customer has rental invoice. Okay. But the customer is not composed of rental invoices. Now the rental item, in the other hand, the rental invoice is composed of one or more rental items. And if there are no rental items, there is no rental invoice. So that's why this is a composition, whereas this was an aggregation. Here the triangle is inheritance, is generalization. This was an abstract class because rental item is general, and these are the concrete classes that you can actually have as a rental item. And this is just association without anything. So rental invoice and the checkout screen are associated, and there can be each checkout screen can have 0 or 1 rental invoices. So I want to tell you that, like, when you draw a diagram like this, it gives you like an overview of the whole system without going into any detail. So this is a little bit better than coding, because then if you're like trying to decide on how to design your program with your teammates, this is so much easier than to have like send them files and programs and functions. This is much easier to understand. On top of that, you can discuss the functionality details and see if everybody is happy with this before you can implement. And most likely they won't be happy with it. Like, somebody will find a mistake with it, and then you'll have to change it. Now, when you're changing things, it's so much easier to change this diagram rather than changing a lot of code that you've written, right? So it's much better to draw some diagrams, even though you're not an artist. Try to draw some diagrams rather than going to coding everything at the beginning. One more example with some multiplicity. The student body has 100 students in it. The student has name and address, and the address is another class. So the student is composed of these addresses. This is aggregation. So how can you create these diagrams? There are many tools out there. These are some old programs, but I think they still exist. Violet and rational rows. I think this is not free. This is also not free. Here are some other free tools that I know. They're a little bit more modern. These are 2 Linux programs for 2 different window managers environments, GNOME and KDE. DI is for diagram, and Umbrello is an UML from, well, they made that name like that from UML. And if you were in class last time, Ting showed us a diagram that she created with an online tool. You just go to the website and you can just click and draw the diagram and you can save it. It's quite convenient. Here I'm gonna take a break again to make sure that the video is fine.